Okay, this one is really short and sweet, so let me know if you have any questions afterwards. It's about intersection and union. The intersection of sets is where they overlap. The symbol for intersection looks like this, and the term is and. Okay, and. The union of sets includes all values of each set and their intersection. So it's the union is everything. The symbol for union looks like this, and the term is or. So if you're trying to remember them, remember, if you're looking for the symbols, this is the union. So the other one must be intersection. Union, the U looking one is for union. If you're trying to remember them versus and or, look at this one, then we can make this look like an A. So this is and then the other one is or. Okay, so we got to be able to distinguish between these two things. And we just have one slide to help us with this. Okay? So, graphing the intervals on a number line may be our best way to determine the solutions. Eventually, we'll get used to them and we won't have to graph them. But right now, graph them on the number line. All right, so I've got this number line that goes at least from 9 to 12. So I'm going to say 7, 8, 9, 10, 11, 12, 13, right? Okay, and do one at a time. This is negative infinity to negative 9. So the negative 9, let me change colors. It's got a parenthesis like this. Negative infinity to negative 9. And then we got negative infinity to 12. 12 also has a parenthesis like this, right? And because we're doing the union, which means or, either one or both, right? It can be either one or both. Oh, well then that where either one or both lies is negative infinity all the way to 12. That's the union. If we were doing the intersection of these two graphs, it would only be this part where they overlap. The intersection is negative infinity to 9, right? Intersection. Okay, now this one has asked us for an and. Oh, and that's intersection. I got to be able to know both terms. And we got negative 3 and negative 9. So let's make some points on here and see where they are. So negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. So make it a little bit longer. Oops. Just imagine. All right, so let's say negative 5, negative 4, negative 3, negative 2, negative 1. I could have went by multiples of 3, might have been better, but just for emphasis here. It's a 4, by the way. Okay. Now, we have less than negative 3. Pointing that way, negative 3. That way. And greater than negative 9. Oh, I didn't get negative. I did a positive. I didn't get negative 9 on here. Okay. So let's just say, nope, I'm not going to do that to you. Let's redo it. I was doing -3 to fit a +9 on, but let's just redo this right quick. Okay. So I need -10, -9, -8, -7, -6. And let's assume these are all the same distance apart, right? Okay, so less than -3. Here's our -3. And the arrow says, let's go this direction. Okay. And then we have greater than -9. Here's our -9, but greater than is this direction. Because it's an and or an intersection, either way it's written, it means it's got to be this and also at the same time this. That's where they overlap. Here's the overlapping area from -9 to -3. Okay, I know that is very short and sweet. Hopefully it will suffice. If you have questions, just let me know.